Welcome to Homework Lib.
Here we're going to set up the reaction table for the following conditions. We're going to have a 250 milliliter flask in which we're going to have the following amount for these compounds, and we want to complete the table below where we're going to list the initial molarity. So in all of the cases, remember that molarity is equal to amount of mole divided by the volume in liters. The volume in liters in this case is going to be equal to 0.250. So the molarity for each of the compounds is going to be the following. For CH4, it would be 1.4 divided by 0.25 mole liter. For water, it would be 1.3 mole divided by 0.25 liters. I'm going to put the standard symbol for molarity. And for H2, we're going to have initially 1.8 divided by 0.25 liters. So the initial concentrations are going to be essentially multiplying each of the factors by 4. So this is going to be 5.6 molar, 1.3 times 4, 5.2 molar, and finally 7.2 molar. So these are going to be our initial concentrations. Let me just erase these spaces over here just to be able to have the results that we're going to get. So the initial amount of CH4 is going to be 5.6. For water, it's going to be 5.2. For CO, we're not going to have anything in our reaction flask at the beginning, but for H2, we're going to have 7.2. So the amount of change is going to be minus x, plus x, and plus 3 times x. So at equilibrium, we would get 5.6 minus x, 5.2 minus x, and 7.2 plus 3x. And with that, we are done with the problem. Thank you very much and have a good one. In this case, if you're given the equilibrium constant, you can calculate the value for x, solving the corresponding equation, and with that you could get the equilibrium concentrations for this reaction in the case that it is asked in another question.